Hello, pre-AP. All right, DCA review. I'm going to run through these kind of quick. Feel free to pause the video as needed. All right, let's talk domain and range. So first of all, remember domain is talking about all the set of x values. So we're talking x-axis left to right. So here's my leftist most point. I mark that on my x-axis. My rightmost point is right here. Furthest left is at -4. It's an open circle. And the furthest right goes through +3, and it's a closed circle. All right, for our range, again, it's least to greatest always. So even if you see in your answer choices some flipped around saying greatest to least, that is wrong. Scratch that answer choice out. All right, we're always talking least to greatest, so least to greatest is bottom to top for our y-axis. At -3, that is an open circle. Up here at +4, that is a closed circle. All right, sliding next door here. Can I mark the furthest left for my domain? Nope, because it's going on to -infinity. Can I mark the furthest right for my domain? Well, yes, we can. It's there at 0. Oops, and at 0, actually, it's an open circle. Open circle. So officially, our answer choice here, remember we drop off that infinity sign, we'd be left with x is anything less than 0. All right, and then for our range, again, bottom to top. Now this one you might have got a little weird on, least to greatest. Well, it goes from -4 to -4 again. So we would never actually write an answer out that way. Maybe you said, okay, well, since it's only -4, y just equals -4. And I would agree with that statement. Now, on your test, however, since we're only talking about one number, what you'll see is they're going to list it as a set of just one number, saying that your range is only the set value of -4, because it's only one number. All right, moving on. We did not have this one on our review, so ignore that, but let's talk about this one. The daily cost of hiring a plumber to work X hours on a repair project can be modeled using a linear function. Plumber charges a fixed cost of $80 plus an additional cost of $45 per hour. All right, remember that per, 45 per, or $45 every day, or each week, or every time. That is the person who gets your variable. So our linear equation here would be y equals 45x plus that fixed cost, or flat rate of $80. Now let's pause and think for a second. What are these things really talking about? Like, I want to know, what does x actually represent and what does y actually represent? So x is not 45, obviously. 45 is the number attached to x. So what x is actually representing in this case is the number of hours, and y is representing the total money made, or the cost, okay? So now that we've thought about that, it says that the plumber works a maximum of 8 hours per day. For 1 day of work, what is the potential range of the function for this situation? So range, we're talking about our y values, so right off the bat, I only can be between b and d. Now let's think about this for a second. XY. So it says he can work a maximum of 8 hours. Well, what would be the minimum amount of work? What about 0? What if he chose to not work that day? All right, so even if he did work 0 hours, so if I plugged in 0 here in for x, 45 times 0 is 0. 0 plus 80, he would actually still make $80 that day. Maybe that's like the customer canceled on him, and they still charge them like a fee for the cancellation. I don't know. All right, so then let's think about what would it be if he made if he worked the full 8 hours. So 45 times 8 plus 80 is $440. Okay, so whenever it's asking what's the range, it's basically asking what's the potential amount of money this guy could make given that he works a max of 8 hours per day. Well, he can make anywhere from $80 to $440. So B would be your answer choice there. So if you see one like this on your test, I recommend making a little table like you saw here, and then writing out maybe whatever like maximum and minimum values you're working with. All right, what is the rate of change? This is number 5. Rate of change for the table below. So you could do this a couple ways. Now you know how to do your linear regression, so you could do your stat edit thing and just plug it into there. Or go old-fashioned, the change of y over the change of x change of y over change of x is 20 over 2, which is 10. And they happen to give me this pretty point, which is a y-intercept. So I get y equals 10x, and my y-intercept is 25. All right, cool. Next one. Determine the slope of y-intercept of the graph, then write the equation. All right, we can do that just visually looking at this thing. Now again, you could pluck off these 2 points or whatever points that you're given, and you could plug these into your stat edit. Again, totally welcome to do that. But hopefully at this point, y'all are figuring out your rise over run. All right, so our slope is negative 2/3, and then my y-intercept is there at positive 4. So y equals negative 2/3 x and a positive 4 for that y-intercept. The next one is number 10 on the very back. All right, so looking at this, it says which of the following equations are represented by this graph. So my first move should probably be, let's figure out the equation of this graph. So rise 2, run 5. So my slope is positive 2/5 x, and my y-intercept is down at negative 4. All right, so that's the goal. That's who I'm looking for. Now, whenever I go to look at these 4 answer choices, right off the bat, I see 1 is negative, so he is out, therefore A is out. All right, so now the rest of these, I got to solve them for y. So I'm going to take this first one. All right, I'm going to subtract the 2x to the opposite side, so I have a negative 2x and a positive 20. Then I'll divide everything by a negative 5. Now I'm still seeing a lot of you guys messing up on this piece. You think if it's negative and this is negative, then the whole thing must just be negative. Very wrong. Negative divided by a negative becomes a positive. All right, and then we end up with that negative 4. So is this one that I'm looking for? Yeah, so 2 is going to be a possibility. So again, I can eliminate option C because that he did not have 2 as an answer. All right, I am going to look at this one next because I can just distribute here. So I'll have y plus 2 equals 2/5 x minus 2, and then I will subtract 2 to both sides, and once more I do end up at 2/5 x minus 4. So this one is going to be a potential candidate as well. Now, this one's already solved for y. If you just plug that one into your calculator to go see, like, I wonder what he looks like. Plug it into your calculator, go look at your graph, and you're like, whoa, that is not the straight line I'm looking for. That's actually a quadratic function. We will work with those next time around, or next semester, I should say. So D would have been your answer here. All right, write an equation. This one is number 7. So write an equation that has the same y-intercept but a greater rate of change than the line below. So my first recommendation again would be identify the equation of this line. Y equals, my slope is up 1 over 1, so 1x minus 5. Now, y'all know me, I don't really prefer to plug in that extra 1. It's assumed. So y equals x minus 5. That is the given equation. So it says to write a new equation that has the same y-intercept but has a greater rate of change. So let me give you 2 options. You tell me or think about which one of these would work. Y equals, or this one. All right, which one of those would have it the same y-intercept? Well, they both have the same y-intercept, but which one has a greater rate of change? So if you get down to some answer choices, you can always plug them into your calculator, go see what the graph looks like, and see which one is steeper. Remember, it does not matter whether it's positive or negative. What matters is the closer you get to 0. All right, so the closer you get to 0, the less steep your graph is going to be. So 1/3, that's closer to 0 than 1. So that means he's going to have a smaller rate of change. So let's say if I did do this, okay, here would be option A. From my y-intercept, up 1 over 3, up 1 over 3, up 1 over 3. Does he have a steeper slope? And the answer there is no, Miss Harper. That's correct. So let's look at what happens with B. I'll do this one in blue. All right, so for B, it'd start here at negative 5, and then we'd have down 5 over 1. And that could go up and over. Now, I know even though it's moving in the opposite direction, you can very clearly tell he is still much steeper than the given line, okay? So you could have had any answer here as long as your y-intercept stayed the same, but this number was greater than 1 or greater than -1. All right, cool. This one is number 9, blah, 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 blah. What is the x-intercept? All right, so here is our x-intercept. Let's write that out as a point. That's 28, 0. Think about what we're talking here. We're saying 28 hours and 0 gallons. So right off the bat, I could eliminate A and B because I know I'm looking for the number 28. All right, and then reading through our answer choices, we're talking about 28 hours, not 28 gallons. So that's out. C would be the appropriate answer there. This one, number 8, easy breezy. I hope you did not miss this one. So remember that $5.50 per line plus a setup fee of $7.50. Our answer choice was B here. And the last two are these. So let's run through these. Remember, whenever we have variables on the opposite sides, we just want our goal is to get them to the same side. Does it matter which side you move them to? No, not really. So let's just say I subtracted these 0.5 m's to this side. And I got 2.5 m plus 6.5 equals a negative 3.5. Don't lose that negative sign. Then I would subtract this over, and I'd be left with 2.5 m equals negative 10. Divide both sides by 2.5. And you again, remember, you could have done this in a different direction. Just we should have still got to the same answer though. Go back to your calculator, make sure that you plug those things in. So you can see here, I went ahead, I plugged in my -4 to the left side of my equation, and then I plugged in the -4 to the right side of my equation, both in for the variable. And whenever you do that, these two numbers should be equivalent. If they are not, then that means you do not have the right answer. So use those answer choices to your benefit. All right, last one, our first step here is going to be hippity-hoppity, distributive property. After we've done that, we're going to combine like terms. All right, so I got some like terms here. That's -16 and a positive 6x. Here I have 2x and okay, sorry, I had somebody come into the classroom, so I don't know what I was just in the middle of saying. But here we go. I'm going to combine like terms. 7x minus 5x is 2x plus that 14. All right, now again, we just want to get our variables to the same side. Now, y'all are pre-AP. I like to actually do this in the same step. So I'm going to add the 16 over there to the right side. Now I'm just left with 4x equals 30. Divide both sides by 4, and you would get x equals 15 halves, or 7.5. You might see that as an answer choice. All right, kiddos, I know you're being super respectful and kind and awesome. For our sub today, Miss Gibbs, shout out to her, and I'm sure I'm having so much fun in New York City. Woohoo! See y'all soon. Good luck on your DCA.